For the second part, we will get into health utilities and how exactly are we going to measure health utilities, and when we do measure them, what do we do with them? So we have some direct measures of utility and direct measures of health utility in particular. We'll talk about rating scale first, and then a standard gamble measurement, and then some time trade-off measurements. The first is our rating scale. This should be pretty familiar to us. We ask pain scales all the time on a scale of 0 to 10. How much are you hurting right now? So we're just asking, and instead of a pain scale, we're using some health outcome scale and asking our participants or patients to rank the outcomes, their health outcomes from most preferred to least preferred, and then we can assign some value to the intervals between their rankings. And we can pull up here just a quick example of this. So we're just asking about, on the left, we're asking about mobility, we're asking about pain, discomfort, we're asking about self-care, anxiety, depression, and on a scale from 0 to 10 or 0 to 100, where do you rank your your desired health outcomes? And with this scale here, so we've given them a few possibilities. So this all ones, so one, 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 and one. These are all just perfect health states. So where would you put this on the scale? And directions here just draw a line to where you would put this on the scale from 0 to 100. And it goes from perfect all the way to dead. So I'm guessing dead would be 0 for most people. But you'd be surprised that some people don't put dead as 0. And then it gives you a couple other health states where mobility is no problem whatsoever, but you've got some other issues, and then another one where mobility is 0, basically 0 confined, bed confined, and then you've got some other issues here. So where would you rank these other two? So uh, with the rating scale, we're just asking people and sitting them down and saying, for this perfect health state, what do you think? And for other health states, where would you rank this on our scale? When using a rating scale, there are a few things we need to take into consideration. First one is this end of scale bias, and I'm sure, again, with our common pain scales in the field as paramedics, pretty familiar with this. You have a lot of patients on a scale from 0 to 10. What's your pain? A lot of patients say 9 or 10. A lot of patients say 1 or 2. So there's a lot of kind of bias to say, well, this is a 10, dead is a 0. Maybe in the middle, that's a 5, right? So we've got this, oops, we've got this kind of a scale bias where I'm not going to really nitpick between 1 and 10. I'm just going to choose 10. I'm just going to choose 0, or maybe something directly in the middle at a 5. So be aware of that. But we can use these rating scales, and these rating scales are used a lot to kind of warm up participants when we're doing research and asking for information pertaining to health utilities. We're kind of warming them up, kind of getting them into that mindset, getting them thinking of how they would rate and how they would think about different health outcomes and health states. But if you just want to use a rating scale, we can also take these numbers and kind of convert them to a standard gamble model, which we'll go over here in a minute. Also, the time trade-off scores, which we'll also go over in a few minutes. So we can take values from this rating scale and use them in our other models and kind of bolster our standard gamble and our time trade-off models. Now we mentioned that standard gamble model. So what is that? Standard gamble model will focus on the word gamble. We're all pretty familiar with that, and our gamble model just kind of fleshes out our preferences under uncertainty. So I don't know if I'm going to get sick or not. So what's my preference? Which way am I gonna lead? Am I risk adverse? Am I risk loving? Am I risk neutral? there's some certain health state that is known to me. It's a certain health state, and then there's an alternative health state that I might fall into, and therein lies the gamble. And the gamble says that that alternative health state is either better or that alternative health state is worse. Um, and those alternatives each have a probability that come with them. And if we think, back to gambling, if you have a poker hand, you've got certain cards. There's a certain probability that you might win, and there's a certain probability that you might lose. So that's the standard gamble model: is you might win or you might lose. And we're going to ask our participants to kind of slap a value on this to visualize our standard gamble model. So I've got some alternative two. This is my guaranteed state. I am um, this is my certain health state. I am certain to be healthy, and then I've got another alternative where there's some probability that I win. I'm healthy. There's some probability that I lose. I'm and here I'm dead. That's a big lose. So what am I, willing to gamble on this one? So the P, the probability, we kind of play with those probabilities. So we will plug in that number P. So maybe there's a 20% chance that I'm healthy and an 80% chance that I'm dead. Well, given that for myself, I'm going to choose alternative 2 where there's a guaranteed health state. So we're going to play with P and that probability until the two choices, alternative 1 and alternative 2, I am indifferent between the two. I don't care if I'm in choice 1 or choice 2. And that probability right there, that is my given health utility. So that's my choice. So again, I'm playing with these probabilities right here. So if I choose alternative 2, there's a chance I could win, there's a chance I could lose, versus a guaranteed win. And what am I going to choose? So I'm going to play with these probabilities, and that's going to tell me my participant's health utility. So maybe it's 20%, maybe it's 80%, maybe it's 90%, but we're going to play with that probability P until our participant is indifferent. You might be thinking, well, why would we play with the probabilities of alternative 1 with the 2, I win or I lose and I'm dead, over a guaranteed I win? Well, sometimes the guaranteed I win is less attractive than this healthy state. So what we do is in this alternative 1 where there are two win and lose, that win is a better option than this guaranteed state. So I can stay in this guaranteed state, and I'm fine, I'm okay. But if I choose alternative 1 and I win, then I am super awesome, right? I am super great. I am super super healthy. I am just perfect. So this guaranteed state isn't necessarily a perfect win. Um, so this healthy state right here with the alternative is usually greater than this guaranteed state. Even given that the alternative 1 kind of coin flip healthy state is better than the guaranteed health state, a lot of people, most of us, are risk averse, and we are more likely to choose a certain health state, just because we don't want to gamble. And we're just risk averse. And so this standard gamble approach uh, tends to give us these health utilities that are higher than they would be with risk neutral people, with risk loving people. This tends to bring out the risk averse nature in all of us. So if I give you a scenario where I can give you a certain health state, or you're going to go get a flip of a coin, you're probably going to pick this certain health state. The third model of measuring health utility is a time trade-off model. So we'll talk about that real quick here. Now, time trade-off is exactly what it sounds like. So We're trying to measure health utility, and we've got a participant who's answering our questions, and he's given two alternatives. One alternative is I've got poor health for a number of years, followed by death. And the next alternative is I've got perfect health for a number of years, but my perfect health years are less than my poor health years, both followed by death. So, how long do I want to live with perfect health versus how long am I willing to live with poor health? Just as with our standard gamble model where we played with the probability numbers and kind of got to a point of indifference with our participants, here we play with the time, the X time, which is our perfect health. So we play with our perfect health years until our participant is indifferent between perfect health and poor health, and how many years they're living until death, and that gives us our health utility. So to visualize this, I've got this state I. Dead is dead, but state I is I'm in poor health, but I can live for 30 years. And I'm perfectly happy living for 30 years, given some little poor health state. Maybe I have high blood pressure, maybe I have high cholesterol, maybe I have acute coronary syndrome, um, something like that. But I can live for 30 years in some sort of state of poor-ish health, or I can go to perfect health. If we go back some slides, we can see that 1 1 1 1 1 it was all perfect health. This is my alternative, but my perfect health, I'm gonna live a little bit shorter, right? So I can go through lots of treatment, and that's my alternative. So this intersection is where I get my health utility. Some unique considerations for our time trade-off model is that is risk neutral. Uh, Most people are risk averse, so we're asking this risk neutral question without any uncertainty, which kind of skews things a little bit. So our time trade-off model typically gives us lower health utility levels than the standard gamble approach. Standard gamble kind of pulls out the risk averse nature in all of us. Our time trade-off model pulls out the risk neutral portion of all of us. But now the question becomes, I've measured these health utilities. I've got these numbers. What do I do with them? And the answer is an incremental cost effectiveness ratio. An incremental cost effectiveness ratio is a type of, as the name suggests, a cost effectiveness analysis. So it takes the cost of our intervention that we're going to do. So it's cost effectiveness. We're not worried about cost benefit. We're going to be doing it. We are doing it. So what is the cost of this intervention, of this program? And then we add in the relative health effects that it adds, and we take and quantify some quality adjusted life years, and what does it cost not only for that intervention, but what does it cost for that quality adjusted life year? So a lower incremental ratio implies a lower cost per final patient outcome. The steps we're going to take, I've got some intervention and I've got some cost of intervention. So I've got my intervention 1, which is my new treatment, my new program, my new project, whatever it might be. I've got intervention 0. That's just the status quo. I'm not changing anything. It is business as usual, not adding anything. And I've got the same with our costs. So what's the cost of that new intervention versus the cost of doing nothing, which carries its own costs. So what are we doing right now? That costs something. What if we added something in? What if we changed something? That's my new cost. And then we add in for our incremental cost effectiveness ratio our health outcomes, our health utilities um, for both of those interventions. So whatever I'm doing now, that's effect zero. Um, so we're spending something. There is a cost to what we're doing now, and there's an effect to what we're doing now. There's a health effect, health utility effect to what we're doing now. And then my effect one, if we implement this new intervention, implement this new project, this new program, what are we adding? What effects are we getting from that new program? And that's my effect one. And again, effect is just our utility, our health utility. We just went over a few ways to measure health utilities. Um, so when we're talking about effect one versus effect zero, that's our health utilities. What do we do with these costs and effects? Well, we just divide them. So, the cost of intervention one, my new program, my new project, minus the cost of my existing status quo, what we're doing now, all divided by the effects, the health utility of my new program, my new intervention, minus the what we're doing right now, and how many health utilities um, are we providing right now. So the change in cost over the change in effect is our formula to get our cost per quality adjusted life year. So that's really what our ICER, our incremental cost effectiveness ratio, does for us, is give us the cost per unit of health that we are producing. So our cost per quality, we're uh, we're funneling money towards a program, and the health effects. What are we spending per health effect? Of course, there are some considerations for our incremental cost effectiveness ratios as well. There is a threshold, so we're going to define some sort of threshold for acceptable costs. So if we go back, so there's a cost per quality. Well, where's our bar? We're going to call that lambda, and uh, our program, our project, our treatment, whatever it may be, is cost effective if that cost per quality, that change in cost over change in effect, is less than whatever we have defined as our threshold. Well, what is lambda? What is our threshold? And if you go back into the literature, pretty commonly you'll find $50,000 per quality gained. So $50,000 per additional quality adjusted life year is the is a pretty common threshold. Anything above that is not cost efficient. Anything below that is cost efficient and should be implemented. That's a pretty old number. There's not a whole lot of science behind it. I've put the paper up, that original paper, up in Blackboard for you to peruse through. Not a whole lot of science behind it. It's kind of a random, arbitrary number. There have been some updates. Again, this is all on Blackboard for you. There's some other papers arguing against qualities, arguing against um, cost per quality. So there's an update that says $100,000 per quality gained is actually cost efficient. And then there's some health economists out there that propose, $200,000 or even $250,000 per quality gained is still cost efficient. So, when you really get into incremental cost effectiveness ratios, where is our lambda, where is our threshold? That's up to you, and that's up to economic theory, and for you to argue and defend on for yourself. Some final closing considerations for incremental cost effectiveness ratios. One is, how do we use these findings? We've gone through all this trouble to measure costs, measure effects, measure health utilities. So at the end, what do we do? This really informs policy, informs treatment at the street level, in hospitals and healthcare systems. But in the United States, CMS, Centers for Medicare and Medicaid Services, are not allowed to use um, these ICER studies. So um, CMS cannot use studies of treatments and say it is cost effective, it is cost ineffective, dependent on the incremental cost effectiveness ratio. Therefore, we will or will not do it. They are not allowed to take those into consideration. That's a large departure from other westernized healthcare systems in the UK and Australia, Western Europe. Um, they do use incremental cost effectiveness ratios to um, to drive reimbursement policy. So whether or not CMS is ahead of the curve or behind the curve is up to you, but these are just some extra considerations to take into account. As always, if you have any questions, comments, concerns, cuss words, please let us know.